Welcome to Statistics. I'm Brian Fisher. We'll be going through a journey of both probability and statistics this semester. The world of statistics is kind of the study of uncertainty and things that we're unsure of and can't really predict. But if all we did was leave the semester saying, well, things are uncertain, that wouldn't be very useful. So statistics is more than just the study of uncertainty. It's how do we look at uncertain, unpredictable situations and pick out what things can be trusted and what things can't. That's at its heart the study of statistics, and I think this is pretty useful for all of us, even if we don't find ourselves teaching math someday. So this semester, we're going to study data, and if you look behind me, you'll see I have some data that we used for another class. And this semester, we're going to learn how to collect data, that is how to create or gather data that's useful and can be used to solve our problems. We're also going to learn how to organize that data into ways that can be communicated to others that might be meaningful. And finally, and maybe most importantly, we're going to learn how to analyze that data, how to interpret it, how to draw conclusions from it, and what can and can't we learn from the data that we have. The first thing we need to do is create a set of shared vocabulary so that we're all on the same page and we can talk about these problems and situations together. The first two words are the words individual and variable. An individual is a person or an object, or all the people or objects in our study. And I know when we hear the word individual, we automatically think that refers to people, and it often does. If you're doing a study about the political preferences of people in your community, or how well someone can do some sort of exercise, those are individuals. But it's important to realize they can also be objects. It can be things you study in a science lab. It could be companies and organizations. So the word individual can be any sort of thing that is the unit or the object that you are studying. Once we've kind of decided what individuals it is we want to study, it's time to think about the variable that we want to study. And sometimes there's more than one variable we're interested in. But the variable is the characteristics of the individual that we want to measure or observe. So if you're studying the political preferences of those in your community, the people are your individuals, and then what they prefer, how they respond to a survey, that's the variable that you're trying to measure. And your survey is the instrument that you're using to measure it. When we think about variables, there are really two kinds. They're quantitative and qualitative variables. Quantitative are those variables that have numerical values to it. So if you ask someone how old they are, that's a quantitative variable. Meanwhile, qualitative variables are things that are categories. So if you ask someone their political party affiliation, that's a category. And as we think about both qualitative and quantitative variables, there are different levels and different degrees to which a number can be analyzed and assessed. So the first, or the most elementary level, is that of nominal data, and that's data that consists of names only. That's your political party, that's things like that. The next level is ordinal data, and that's when you can put the data in order. So maybe you know which of these categories, which of these results is larger than the other one, but you don't have a lot of other information. You wouldn't want to take these numbers and actually do math with them. And by the way, we'll give some examples in just a minute. Interval, a interval level of measurement, is when there are differences between the data that are meaningful. So you can not only can you say which number is bigger than the other, but you can say how much bigger, 1 unit or 2 units bigger. And then finally, ratio is where ratios make sense, and that means it makes sense to say one value is twice as large than another value. So let's think of some examples. Suppose, for example, that we wanted to study people's cooking preferences, and we wanted to learn about them baking cookies, for example. And we had everyone come in and create a recipe and try the recipe and rate the recipe. Then a nominal level of data would be to ask this person, what type of cookie did you bake? Notice their answers are only going to be things like chocolate chip or sugar cookies or snickerdoodles or whatever type of cookie they chose to bake that day. Now, what's important is to recognize that when you're done, you will have asked this question to a bunch of people, and you'll have said, 75% of the people in the study baked chocolate chip cookies. I know 75% is a number, but that doesn't make it quantitative data. It's still qualitative because the question you asked was, what type of cookie did you bake? And the answer they gave was chocolate chip. And chocolate chip is a category. So nominal is where we're dealing with a name only. And you can kind of see that in the word nom, in nominal. Ordinal might be if you ask the people, rate the cookie that you just baked on a 5-star scale. Notice, if they rate one cookie a 5 and another a 4, it makes sense to say the 5s are better than the 4s. So we can put all of their ratings in order, or different people's ratings in order. But what we can't say is, we can't say, well, that is 1 star better than another star. Because is the difference between a 1 and a 2 star the same as the difference between a 3 and a 4 star? In my mind, there can be big gaps and differences. So we can't really make comparisons between how much better it is. We can just say if it is better or isn't. An interval would be if you ask someone, what temperature did you bake your cookies at while you did your recipe? For example, if one person says, I baked them at 300 degrees, and someone else says, I baked them at 400 degrees, then you can definitely say that the second person baked them 100 degrees higher than the first person. And so we can definitely talk about the difference between those two numbers. What you wouldn't say is, you wouldn't say that someone baked it twice as hot or twice as high as the other person. So for example, someone baked it at 200 degrees and someone else at 400. Is 400 twice as hot as 200? You know, I don't think that really makes sense to mention that. And so instead, we'll only talk about differences between heat, but we won't talk about ratios between the heat. And a ratio question might be, how much sugar did you use? I used 2 cups of sugar. So-and-so used 4 cups of sugar. They definitely used twice as much sugar. And so that makes complete sense to talk about those levels of measurement. So these levels of measurement aren't the most critical thing that we'll do, but in some ways they're very important, because as you think about data, you think about the numbers that we collect, it's always worth stepping back and asking ourselves, what do these numbers mean, and what do they represent? And when am I able to say useful things about them, and when am I not able to say useful things about them? And these are worthwhile questions for us to be asking. All right, the final thing that we're going to talk about is, as we think about statistics, we think about the statistics and it relates to a population, and a population is every individual that you might want in your whole study. So if you're studying political preferences of people in Lubbock, the population is every single person that lives in Lubbock, right? And a parameter is some characteristic or some numerical measure that describes that population. So if we said we took everyone in Lubbock and we said 75% are affiliated with the Republican Party, then that 75% describes the entire population. But it turns out populations are generally hard to study and hard to understand. And so for that reason, we usually are analyzing samples. And so samples are when we have only some of the individuals of interest to our study. And this makes sense because it might be hard to go find every single person in Lubbock and ask them a question and have them write down a piece of paper. I mean, in fact, unless you work for the city government, your odds of doing this are probably pretty close to 0. So instead, we're going to take some smaller collection of individuals, maybe just 50 or 100, and let those individuals represent the entire population. So that's our sample, the smaller representation. And when we have a sample, we talk about a statistic. And so a statistic is just the numerical measure that represents the sample. So our statistic might be that 75% of the people we study identifies Republican. Now that's not the same as saying the parameter is 75%. But what statistics is all about, and this is kind of the big idea of this semester, is that by studying samples and by studying statistics, we can make really good estimates of the parameters. And that's kind of the big idea of the semester and the last thing that we get to. So now that we've created ourselves some shared vocabulary, the next thing we might want to do is explore actual studies and actual research that we might want to do. So begin by asking yourself a question. What's a question that I'm interested in that statistics might help me answer? And then go further and say, well, what sort of individuals might be involved in answering this question? Who are my individuals in this study? What are my variables in this study? Are they qualitative? Are they quantitative? Are there some of both? And finally, is it possible for me to explore the entire population of this study? Or am I going to need to use a sample, use some smaller collection of individuals to study this? Once you've done these things, write them down in your notes and bring them to class and we'll discuss them. I'll see you next time. Bye.